Hello everyone, how are you? I'm sure all of you are doing great. As I promised in my previous video in which I had taken a BERT introduction, I promised you to take the another lecture on a BERT. So today I'm gonna take a sentiment classification using a BERT. So before we start with this lesson, I should first tell you that if you are very new or pretty much new to the BERT, then you should watch this first lecture. So in this first lecture, I have given the introduction about BERT and what are the other model similar to BERT. And if you want to take a deeper in-depth knowledge about BERT, so this BERT was published in 2018 and by Google engineers, and the primary author was Jacob Delvin, and you can download this paper from this link there. So you see there is a PDF. You click on there, it will automatically get downloaded there. You do not need any special permission to download this paper, and then you can read this paper, and if you want to have an in-depth knowledge. All right, apart from these video lectures and the original paper, if you want to also have a more understanding that how Google searches uses BERT, then you can read this. You can read at this link that understanding searches better than ever before. And apart from that, if you want to know the more information about the BERT, then you can also read about the BERT at these two other places as well. All right, perfect. And now let's go ahead. First, set their runtime. The first of all, you need to set their runtime to a GPU since it is set to a CPU. Otherwise, it will take a lot of the time to process overall data. All right, save it. And if you are new to this Google Colab, then you need to go at this address colab.research.google.com and then open there a new notebook. And once you open a new notebook, then you will get a notebook similar to this, and then you can get started working with this lecture. All right, now let's go ahead and understand what is a BERT. So in this lesson, I'm just gonna take very introductory lesson on a BERT, and then we will start our coding for a sentiment classification. All right, and apart from this, let's go ahead and get some space, and we can get some space from here. Let's go ahead, click on this one, then it will hide other the headers and that profile pictures, all those things. Then we will get a lot of space to work on this. All right, so let's go ahead first understand what is BERT. In a very short, BERT is bidirectional encoder representation from the transformers. And this is actually a very game-changing techniques developed by Google. In 2018, Google has came with this model BERT. Nowadays, BERT is really very widely used model. Everywhere now, the people are using these BERT model in their NLP. So you can say that the BERT is kind of the resonating image processing. All right, so the BERT is designed to pre-train deep bidirectional representation from the unlabeled text by jointly conditioning on the both left and the right context in all layers. That's mean if it says that the left and the right context, that's mean on the given sentences, it takes the context information of a particular sentence on a given after that sentence and before that sentence context. All right. Perfect. For example, if I say that I want to open a bank account, then let's focus on the bank. And then I say that I was walking on the river of bank. All right, bank of river. So what would you see there? There is a bank. The context of bank is different in the first sentence, but the context of bank is different in the another context. So the BERT takes this context while evaluating the words. So that's why the BERT is most powerful framework, NLP framework in the current age. All right. So we have there in the BERT, we have a pre-training and a fine-tuning. So the pre-training is trained on the 7,000 books and around 2.5 billion the words of Wikipedia there. So the combinedly it was around the 3.2 billion words, combined words. So it was unlabeled, or you can say unsupervised learning at the first stage in the BERT, and then in the final stage when we want some output in the form of the classification or the tagging, then we need there a fine tuning. That's mean we do a fine tuning on this pre-training of the BERT network by applying a low data set with the actually labeled data set, a labeled data set like those labeled data set like MNLI, NER and the squared data set. So on these data set it is applied then. All right, perfect. So there are the two existing strategies for applying these pre-training language representation. Those are the feature-based and the fine-tuning. So on the base of this feature-based and the fine-tuning, there were two most popular the NLP frameworks. Those were Elmo and the OpenAI GPT. If you watch my previous video, then I have discussed these Elmo and the OpenAI GPT framework there. All right, but the problem with these two frameworks were that they were not the bi-directional. That's mean they were not taking the context before and after a particular word or a sentence. So they were not pretty much accurate. So that's what was the problem. And generalization of Elmo and the OpenAI GPT NLP model framework was also pretty much difficult. So that's where this the BERT has came into the picture, and it has suddenly changed the scenario of the NLP, and now it has become a game changer in the NLP. So you can say it is the ImageNet, like we had the ImageNet in the image classification. Now you can say that this BERT is ImageNet in the NLP framework. So why we should use BERT? We should use BERT because it is accurate, and it can be used in wide variety of tasks, and it can be customized very easily. You only need to add a few layers in the output to convert it for your customized task. And of course, this is the game changer in the NLP. You can say the BERT is ImageNet in the NLP. All right, perfect. So the BERT is for the beginner. Coding with the BERT is pretty much difficult. So we have here the another framework. What it do? There is a ktrain. So this ktrain do you can say it's like a keras API. So the keras do wrapping of TensorFlow APIs in the simple form. So the ktrain also do the same things. Ktrain also wraps keras and TensorFlow APIs in even more simple form. So if you are absolute beginners in the NLP, then this is the perfect Python package for you to get started with the NLP. So the ktrain wraps the NLP frameworks in the easier format as well as the TensorFlow framework as well. All right. So this ktrain was built to help build a faster model and debug faster, and also the simple deployment. All right, and this ktrain uses the tf.keras. Do you remember that? Before the TensorFlow 2, in TensorFlow 1, there were a standalone keras package, but after the TensorFlow 2, the keras has been the integrated part of the TensorFlow package. All right. So what are the advantages of using a ktrain? You can actually know more about the ktrain at this page there. If you open this page, you will get more information about the ktrain there. All right. So there you have a ktrain. In the ktrain you have yes. So there you can get a total overview. In the news and announcement, you see the latest release of the ktrain is 0.15, and apart from that you can also get the whole package of the ktrain inside there. So all the codes are inside here. All right, so these are the pretty much a wrapper for the keras as well as the NLP like BERT. All right, perfect. So these are the things are there. You see what happens there? It has actually wrapped all the NLP APIs and the keras APIs. All right. So what are the advantages of using ktrain? Ktrain estimate an optimal learning rate for your model. So if you have worked previously with the deep learning model, you need a learning rate. So with the ktrain, you can find out the optimal learning rate, and it can also with the help of the ktrain, very easily you can also employ a learning rate schedules, learning rate schedulers, which actually changes the learning rate on the fly. And this is really very easy, and it's pretty much easy. So at the first instance you will understand, and then you can get started with this ktrain. And why it is the ktrain is important? Because it wraps most famous deep learning models like NVSVM, fast text, GRU, pre-trained word embeddings, BERTs. All these things are already wrapped in the Python wrappers. So you don't need to go from the very basics to build your own models and test them. Alright, so all those things are already available. For the image classification, it has the ResNet, wide residual networks, inceptions, etc. are already these networks are already wrapped inside this ktrain, so you can use these things very easily. Then you have the load and the pre-processed text and the image data from the variety of the formats. Alright, so you can load the text data from the CSV, from the pandas data frame, from the internet directly, from the local machine. So all these things can be done very easily in this ktrain. All right, perfect. So this is all about the introduction. Now we have reached at the most important and exciting part of this lesson. We are gonna set up our notebook, and then we are gonna install the necessary Python packages, and then we will be importing the data. That's the Amazon reviews data, and then we will get started working on the model building and the training. Alright, now let's go ahead, get started with the installation of a ktrain. You can simply install this ktrain in Google Colab notebook with the pip install ktrain. Alright, so if you have not installed, if it is the first time, then it is definitely gonna take some time. So I have already installed the ktrain in my the Google Colab. That's why it is saying that all the requirements are already satisfied. Otherwise, if it is the first time, then definitely it is gonna take a lot of the time. So just for saving space, I'm gonna delete this output, although this is not gonna delete the installation. So all the installation is already available in my this Google Colab notebook. Now before starting with our sentiment analysis, and we will be doing the sentiment analysis on the IMDB reviews dataset. So the first of all, let's go ahead and download that IMDB reviews dataset. So that IMDB movie reviews dataset, you can download it from my GitHub repository. You need to visit there, Lakshmi Merit IMDB movie reviews, the large dataset. So there you need to get there this address. So I'm gonna just copy this address from here. So it has copied this address in this address. But before that, let me explain you from where I have got this data. I have got this data from the Stanford University, and in this Stanford University, I had downloaded this large movie review dataset. So this large movie review dataset is kind of not as much organized as it seems in my Let me show you. It is here. All right. So it seems in my GitHub repository. All right. So what I'm gonna do here, the first of all, let me first get it here. So you have here IMDB movie reviews large data set. I'm gonna take this address. All right, so I'm gonna just copy it. Once I copy it, then again I'm gonna, in my Google Colab notebook, there I'm gonna write here git clone. All right, so it is gonna clone this whole repository which I had there. All right, so there I had this repository. So this repository will clone in my this Colab notebook. All right. So since I already had downloaded this this data, that's why it is saying that this is already available. So if I delete this folder, let's say if I delete this folder, let's say, all right, it might take a little time to delete. In meantime, also I want to delete this folder as well. All right. So let's go ahead and run it. And if it is the first time for you, then definitely it is gonna take a very less time. Okay, it is still there. It's not the deleting. Well, it says that it is not the empty, only the empty directories can be deleted. Anyway, so this is the way how you can download the data. I mean, how you can clone the data, which is already available at my GitHub repository. And in this, we have here our train and the test set. All right, so this train and the test set includes the positive and negative reviews of a particular movie. So we'll be using our BERT model by the help of ktrain API wrappers to classify whether it is the positive review or the negative review. All right, so the first of all, let's go ahead and get the address of this train.xl file. So I'm gonna just copy this path, and then I'm gonna import here necessary Python packages. So those necessary Python packages are import numpy as np, and then I'm also gonna import here pandas as pd, and then I'm gonna import here, I'm gonna import TensorFlow as tf, and I'm also gonna import here a ktrain. All right, so this is the ktrain Python package or Python library which we had just installed. And from this ktrain, all right, so from this ktrain import text. So I'm gonna import a text module from this ktrain. All right, so once you run this cell, all these will be imported in this Google Colab notebook. All right, so we already have this path, train.xl path. Now we need to read it into the pandas data frame. We can simply read it with the pd.read_xl. all right, so there we have got it, and then the data type which we are going to read it in the form of str, that's the string data type, and I'm going to read it into a data_train variable. All right, so there I have data_train variable. So in this data_train variable, I have this pandas data frame which have a reviews and the sentiment. So each of these reviews are the text data which we will be feeding our BERT model, and this is the final target label, or you can say the output label, according to which these will be classified. So the first in the training, from the data train, it will learn, and then from a data test we will try to find out the accuracy of the classification. All right, So in the same way, we are gonna do for the data test. So I'm gonna just copy it for a simplicity, and then I'm gonna put it here, data underscore test, and then finally here I'm gonna put there test.xlsx, and everything will be same there. And there again I'm gonna also do for the test data set as well. Now you should notice here there are 25,000 rows for the training as well as the testing data set. So this is for the train. Let's go ahead and see just first few head now. That's the first few line actually from a head. So head shows only the first 5 lines of any data set. All right, so this train data set have 25,000 rows, and this test data set have 25,000 rows. All right, so we have now our train and the test data set ready. Now let's go ahead, call this text module from the ktrain to read these data set. So how we are gonna do this? We are gonna do it with text dot read. All right, so there, text dot text. So once you write there text dot text, then Google Colab will automatically get started suggesting you the best thing which we need to apply here. So we need texts from the data frame. That's mean we are gonna load a text data from a pandas data frame. Now once you put there a round parenthesis or bracket, then you will get a required input arguments which we need to pass this text from DF. So the first of all we need to pass their training data frame. So let's go ahead, write their train underscore DF, and there we have data underscore train data. All right, and the second it asks about the text column. All right, so that's the text column. Which one is the text column in our case? All right, so the text column in our case is reviews. All right, so there text column, we have reviews. So this reviews is the text column in our data set. Then we have a label columns. All right, so the label columns is a target columns, and there in the label columns we have label column of a sentiment. All right, so you see there we have a sentiment. So this is how we have given a training data set and the corresponding the text column and target columns. Apart from this, now we need to give there a validation data frame. So there we have valdf, that's the validation data frame. So in the validation data frame we have data underscore test. All right, now after this I'm gonna leave this max features 20,000 as it is, and I'm gonna change this max length. All right, so this max length says that what will be the text length which we are gonna feed to our BERT model. Do remember the some reviews could be with the more than 400 words, and some reviews could be even less than 100 words. So there we are gonna say that the max length. All right, so there we have here max underscore length. I'm gonna give here a 400. All right, okay, so the maximum you can give there a 512, but once you give a 512 on this Google Colab notebook, it takes around 3 to 4 hours to train this model. But if you give here just a 400, then it takes around 1.5 hours or 1 hour to train this complete model. So optimally, I'm going to select it 400 so that we can finish this training in a less than hour. All right, so the n-gram range, I'm going to keep it 1. Otherwise, if we put here a 2, then a memory, the exhaustion will occur. So all the memory will exhaust there. All right, so, and apart from that, now I'm going to say there a pre-process mode. So the pre-process mode means the tokenization, embedding, and the transformation. So which we are gonna use here? So we are gonna use in the pre-process underscore mode BERT. We are gonna use here a BERT. So all the tokenization and the embedding will be done with the BERT. All right. And after this, if you see at the last of this, let me see if we have more information. I think we don't have much information, but the thing which it returns, as you see there, it's pretty much clear that it is taking the training data frame and validation data frame. You can understand this like a train test split, which we have been doing in our scikit-learn packages. So the train test split takes the x and the y as an input, and then it returns the x train and the y train, x test and the y test. So in the same things, it is gonna also return here x test, y test, and the y train and the y test. All right, so it is gonna return there two tuple. So the one tuple will be for training, and the one will be for testing, and then there will be a third parameter which is a pre-process. So this pre-process contains the information of a pre-process mode and other information. All right, so there we have here pre-process. All right, so this is the pre-process, and in this pre-process, okay, text from the df, so I'm gonna give there x underscore first train. All right, then there we have y underscore train, and similarly we have x underscore test, then y underscore test. Let's go ahead and run it. So it might take a little time to complete it. It says that we have got there max len. Okay, so this should be not max underscore len, but it should be the max len. All right, so it might take a little time to complete this process. So how it is doing, it is taking this reviews in a text column and sentiment in the label or a target column, and then there is a wrapping of a 400 words for each of these reviews. If reviews are less than the 400 words, then the padding is being done there, and if reviews are more than 400 words, then truncation is, I mean after the 400 it is truncated. And the pre-process mode, that's mean the NLP model which we are gonna use here, that we are gonna use here a BERT NLP model. All right, so it returns these three parameters. Essentially these are actually 5 parameters, but these are the two tuple, and then there is a third parameter. So it returns the x train, y train, x test, y test, and pre-process. All right, perfect. So, and one more thing, it automatically detects the language of the text data. It automatically detects, it has detected that this is the English language. And apart from that, it also automatically detects that is it a multi-level classification or a multi-class or a binary classification. So these are the beauty of this ktrain. You don't have to do a lot of the hard works on preparing your model from the scratch, and the later you find that you have missed something and this model is not working. So all these things comes as an inbuilt package with this ktrain. Only you need to pass your data and the type of pre-trained or pre-built model which you want to use, and then the rest of the things are automatically being done by this ktrain. All right, so all these pre-processing and loading is done. Now what I'm gonna do here, I'm gonna check the shape of x train. So there we have x train shape. So it says that this is the list object. Yes, this is actually a list object. So I need to first get this 0th array. All right, so 0th element, then we will get there a shape. So it says that we have here 25,000 rows and there are 400 columns. All right, perfect. Now let's go ahead and get our BERT model. So we can get our BERT model with the model is equal to text underscore classifier, and there I'm gonna pass So there you see there are many models available in the ktrain. We have a fast text, we have NVSVM, we have their logistic regression using embedding layers. Then we have here a bidirectional GRU, and then we have here a BERT model and distal BERT for Hugging Face distal BERT model. All right, so here I'm gonna use first of all a BERT model, and then we have given a name of the model, and after that we need to give their training data set and then pre-process. All right, so there we have a train underscore data, that's the training data. In this training data we have X train, and then we have here a Y train. All right, and similarly we have here our validation data. Let me show you. All right, so similarly we have our here a validation data. In this validation data we are again gonna give here X test and then Y underscore test. All right, so we have given here our the validations. Yes, so the training data and the validation data. Now what I'm gonna give here, now I'm gonna give here, after this the training and validation data set, I'm gonna give here a pre-process. All right, so the pre-process means the model which we have used for a pre-process. So this information actually returned from this text from DF, and that is here in this pre-process. So you can simply copy it and then you can paste it here. All right, so with this we will get there a model. It says that there is error in this validation. Actually, sorry, so we actually don't have here, we actually don't need to give validation data there. All right, from in the text classifier we will give that validation data set in our learner actually instead of this model. So our BERT model is now ready. That means this BERT model has been transferred in this model variable. Now what we are gonna do here, now we are gonna get a learning rate. Now you do remember this is the most the difficult and tricky task. All right, get learning rate. So the learning rate, if you have worked previously with the deep learning models or neural networks, you should you have given at least some learning rate to your model. So according to which your model will learn. And I'm sure at the very first time you might not have got optimal learning rate. So in this ktrain, it has a function to find out the optimal learning rate. So what it does, it changes the learning rate from almost zero to some extent, so that it can find out optimal learning rate. So the method to get the learning rate, it's actually, there is learner. So let's go ahead first get the learner. So there we have a learner. All right, so in the learner we have here ktrain, all right, dot get underscore learner. So once you write there ktrain dot get, it will give you there ktrain dot get underscore learner. Then there you will get here a model is equal to model. So this is the model which we have already got earlier. All right, so this is the model. All right, so once you get that model is equal to model, and then again we are actually going to give here the training data. So I'm just gonna copy it from there and then I'm gonna paste it here. So that's the train data, and then I'm also gonna give here a val data, that's the validation data. So there I'm gonna give here X test and then Y underscore test. All right, perfect. All right, so this is the validation data. X train we have already given. Now finally we give here a batch size. All right, so there is a batch size. So this batch size we are gonna give here a 6. All right, perfect. If you read this ktrain, the code at the GitHub, you will find that if we select our maximum length somewhere around 500, then we should give a batch size of a 6. That's why I have given here batch size of a 6. So if you change your max length, then you should get your batch size first from the GitHub code. You can inspect that and then you will find that what is the batch size. All right, so there we have got here a learner. Now once you have got the learner, then you can get their optimal learning rate. So how you will get optimal learning rate? So the learner dot lr, all right, underscore find. So that's the learning rate find, or you can say the lr finder, and then there we have learner dot lr underscore plot. So it will plot a learning rate. All right, and then it will show you which one is the best learning rate, which is gonna suit best for your model. But do remember, it is gonna take a lot of the time. All right, so this might take days to run. All right, so this might take a days to learn. All right, so this might take 2 days or 3 days. So what I'm gonna do here, I'm gonna comment it. Why I'm gonna comment it? Because with the pre-training, all right, so pre-training optimal learning rate for this model is the 2 power, that's 2 into 10 power minus 5. Do remember, this is only for this problem. So if you have any other problem apart from this sentiment classifier, then you should run these the 2 line of code to get optimal learning rate. So I had run this code, so it took around the day to get this optimal learning rate. So I had found that, okay, so this is the 2 into 10 power minus 5 is the optimal learning rate. All right, so let's assume that you have got the optimal learning rate. Now our task is to train our BERT model. All right, so we have reached into the final part of this tutorial. So there we are gonna train our BERT model. Do remember, this training might take a lot of the time, at least 1 hour or 2 hours it's definitely gonna take. So the learner dot fit, do you remember that we have a model dot fit before compile in our neural network, after compile, and before a fit we had a compile. So the compile, you can understand that compile is kind of getting this learner. All right, so this is kind of compiling our model there. All right, and in the ktrain we have there many optimal ways to train our neural networks. So there we have a learner, so you can assume that learner is kind of a model dot fit one cycle. So this fit one cycle is actually an algorithm. All right, so this is a fitting algorithm there. All right, so this fitting algorithm works actually very great there. So in this fit one cycle, we will just run it for a single epoch there. And learning rate for this, I'm gonna pass there 2 into e power minus 5. That's mean 2 into 10 power minus 5. And epochs, I'm gonna pass it here 1. Do remember that even this single epoch, it's definitely gonna take a lot of time. So at least 1 hour to 2 hours. And don't go for 10 or the 20 epochs. You should go maximum 2 or 3 epochs. Otherwise, after that, definitely this model will overfit and it will consume a lot of the time. Huge time. All right, so let's go ahead and run it, and then we can get some information that how much time it is gonna take. For me, it took around 80 to 90 minutes. All right, so what we are gonna do here, we are gonna wait some time. Alright, so it has been almost 2 hours for training, and it seems it has almost finished, but I have been looking since last 10 minutes. It seems that this notebook has got stuck, and it is not able to actually update this value, but at the background it seems that the training of this model is already done. So to overcome this problem, what I'm gonna do, I'm gonna stop this execution. Even though if I stop this execution, it is gonna keep all the learning parameter. As you see there is just 4 steps left to update it, but technically I think it is already trained, but somehow I think in the middle I had lost the internet. That is that could be a reason. Perhaps that is why it is not able to update this value. So I'm gonna stop it. Alright, so once I stop it, although it might seems that it has thrown the error, but anyway, this is not actual error. And apart from that, if you see there, earlier you see there, there were 4 samples were left to train it. But once I stopped this training, it seems that all the samples are trained, and the accuracy, it seems here around 89%. Alright, so let's go ahead and see if we have our learner here. So if we execute it, it seems that yes, we have our learner. That's mean this is a learner. Alright, now what we are gonna do here, now we are gonna predict it. And how we can predict it, we can do with the predictor. So there is predictor is equal to ktrain dot get underscore predictor. Alright, so we have got here a predictor, and then I'm gonna get it model. Alright, so that model is we are gonna take from learner.model. So with this we have got a predictor. Alright, and it seems that it is missing one parameter, which is a pre-processed parameter. So this parameter we already have. It's a pre-processed parameter which we had, I think, passed. Let me see here. Yes, so we had passed this parameter in the model, and we got that parameter from text from DEF. Alright, so with this we have got here a predictor, and after that let's go ahead and create a data set here, and which we will use to test our data, test our model. So I'm gonna say that this movie was horrible. Alright, the plot, let's say, I'm gonna say that here, sorry, the plot was really boring, and I'm gonna say that acting was okay though. Alright, so this is the one review which I'm gonna test, and the another review I'm gonna say that the film really sucked. I want my money back. Alright, and the another one I'm gonna say that what a beautiful movie. Alright, great plot, great acting, we'll see it again. Alright, so this is the data, and now I'm going to pass this data in the predictor, and then we will see what is the sentiment of these 3 reviews. So that we can do with the predictor dot predict. Alright, and there I'm going to pass this data, although it seems that this is executing. Yes, it is executed. Let's go ahead and run it. Once you run it, then you will see each of these reviews will be classified in the form of the sentiment, either a positive sentiment or a negative sentiment. Alright, so it says that the first one is negative sentiment, and it has classified there. This is the wrong classification. This says that this is the positive, and third one is definitely a positive sentiment. As you see there, the accuracy was, how much accuracy? Accuracy was 89%. So with that, we can see that, okay, so if this is wrong, let's go ahead and check the another one. Okay, so let's say the film, I'm gonna say that let's say the film really sucked. All right, and then let's say there is no plot and acting was bad. Let's go ahead and check it and see in this what will happen. All right, so it seems, just wait a second. Sometime this notebook gets some time in execution. So it says that now it has correctly predicted that, okay, this is negative, and this is a positive sentiment. All right. And apart from that, this is how you can predict it. All right. And if you want to save this model, and you can, and if you want to utilize this model later on, then how you can do it? You can simply save this model as well, like predictor.save. All right, so I'm gonna save it there in the content. The content is this contents is main. This is the root of this collab. All right, and there I'm gonna say that BERT. All right. So with this, it will save this BERT model, and then you will be able to see this here. And it's not yet saved. Once it gets saved, now it is saved, refresh it, then you will see that BERT should come here. All right, just wait a second. And it should come here. I think it is not refreshing, otherwise it should have come here. All right, so there we have this contents and in the BERTs. Otherwise, how you can understand it in a more better way, like let's say if we get the address of this path, then it says that this is actually not contents, but in fact it is content. That is why it was not coming there. All right, so it's a content, and then there is a BERT. All right, once it save it, then with the refresh, you should be able to see there a BERT. All right, so there we are able to see this BERT. In this BERT, we have TensorFlow model, that's the TF model, H5, which is 1.22 gigabyte, and then here we have this preprocessor. So these are the two things which is saved inside this BERT, and then you can, I think, then you can use this BERT model for the later on for your use. All right, perfect. So this is all about in this lesson. Thanks for watching, and I'm sure you have enjoyed this lecture. And I'm really sorry for this one, since I think this Jupyter notebook got hanged. That is why I had to manually switch it off. Otherwise, it was really going pretty well, pretty much very good. All right, perfect. So this is all about in this lesson. Thanks for watching. In the next lesson, I'll take more videos on the ktrain and BERT. See you in next lesson. Bye-bye. Have a nice day.